In the next slides, I would like to give you some information about the ROC analysis, which is a commonly used analysis to calculate thresholds, diagnostic thresholds for diagnostic for tests, for laboratory tests. So this is how a ROC analysis, a ROC graph looks like. You probably have seen or will see many this kind of graphs with one or single or more than one line and with this ROC abbreviation in scientific articles. I would like to explain how the ROC analysis functions and how we decide on these thresholds. Here I have some data with me. Let me open this Excel file. Here you see this is about platelet distribution width or anything. Imagine any laboratory measurement. Forget about the platelet distribution width or what. But this is used to put a label to diagnose patients. Let's say we want to diagnose an infection, whether the patient has infection or not. Is platelet distribution width usable for diagnosing infection? I don't know. Let us see it together. So if you have this platelet distribution width, as you see, is ranging from 6.2 up to 22.9. And if you use a very low cutoff, very low value for diagnosis, like 6.2, you will have a 100% sensitivity because all your patients will have this low level of minimum level of platelet distribution width. Everybody will be above that level. So you have to label all your patients with having the disease, with pneumonia or infection. So what about the specificity? If you label all your patients as sick, of course, the specificity will be low. You will label healthy people as sick as well. Although they don't have an infection, you will mark them as having the condition. Therefore, the specificity of that test with this threshold would be very low. For that purpose, scientists have proposed to calculate this likelihood ratio or the Uden index. A scientist called Uden has developed another index. Let us look first to the likelihood ratio because I have given you the formula before. The likelihood ratio was what? Sensitivity divided by 1 minus specificity. So 1 divided by 1 is 1. The likelihood ratio of this test with a threshold of 6.2 would result in 1. Whereas Uden has suggested a little bit different formula. He suggests to add up sensitivity and specificity and subtract 1. So 1 plus 0 minus 1 would be 0. This is the Uden index. Our purpose, of course, is to have the highest possible here, the highest possible point with the highest sensitivity and highest specificity. That means some point where the curve is approaching this corner here. We are looking for this corner. Each dots here on this curve represent one threshold, one measurement. So as I go increase my threshold from 6.2 to 7, 8, or 9, let's go up until 10, you see my sensitivity will decrease. However, the specificity is increasing and the likelihood ratio is increasing as well. And also of course, the Youden index. So my purpose is to find the maximum Youden index or the maximum likelihood ratio. If you have a good data set, you should come up with a point where you have where you easily can recognize the maximum Youden index. Probably for this data set, I would say that this here is 0.43. It has the highest Youden index. However, the likelihood ratio is also high. It is 5. We mentioned that above 2, you have a test is usable, fair to high, moderate likelihood ratio. This one gives us 5. So, but the another issue here is as you increase your threshold, your likelihood ratio keeps increasing. But for what? You have higher specificity, but you lose your sensitivity. We don't want to have very low sensitivity as well, because our primary goal is to diagnose people, isn't it? So we want to have a high sensitivity together with the possible high specificity. And in this case, a cutoff or cutoff point of 12 would be probably appropriate. But this is not an ideal data set to demonstrate this to you, I know it. Or even this graph here is not ideal. You see, this is the 50% line. If your ROC curve is approaching this line, that means it has less value. So you should have a ROC curve with the highest point approaching this corner, and this is here in this example not the case. So a CRP in this example, another example from a journal, a CRP lymphocyte ratio cutoff was used to diagnose appendicitis, perforated appendicitis, and it has a cutoff. They used a cutoff value of 0.4 to predict perforated appendicitis, 0.4, and that level, that threshold, has given us a sensitivity of 0.7. These are the confidence intervals, low, higher confidence intervals. So 70% sensitivity, it's good, isn't it? 70%, and very much higher specificity. And here we have the positive predictive value, negative predictive value. The positive likelihood ratio, it is 19. Remember, a value above 2 would be useful. So 19 is also pretty good. And the positive predictive value is also almost 80%. So all these indicators are suggesting that this threshold, 0.4, is a good choice to put to decide on diagnosis or to assist the surgeon in diagnosing perforated appendicitis. What would happen if you increase your threshold? You should be able to answer this question actually. What would happen if you increase your threshold? The sensitivity would be lower, of course, because with the higher threshold, you will miss some of the deceased people, but the specificity would get higher. Okay, let us make another break here.